All right, let's solve this problem. We have this limit problem that says limit of square root of 1 plus x minus 1 all over x when x is tending to 0. Now, if we decide to plug in our 0 into the x, this will be undefined. Therefore, in that case, we're going to find a way to simplify this fraction and make this fraction to become defined for us to plug in our 0. And in order to do that, we're going to take advantage of this sort form here by adding the conjugates of the numerator of this fraction to multiplying the conjugates by both the numerator and the denominator. And let's go ahead and do that. That will be limits of this square root of 1 plus x minus 1 all over x multiplied by the conjugate, which is 1, sorry, this is x, sorry, 1 plus x. Instead of minus, you're going to have a plus all over the square root of 1 plus x plus 1. Right, so why we are changing this sign is because we want this to cancel this out. We want to use this to simplify the numerator, right? And then take advantage of this as well to cancel out this potential undefined denominator. All right, so now let's go ahead and do that. That means this times this. Whenever we multiply a square root cancels out square root. So we're going to have just what we have inside, which is 1. The limit now is going to be 1 plus x. That means when x tends to 0, when x tends to 0, the limit now is going to be this. That this times this is going to give us x plus 1. Then square root of 1 plus x, sorry, 1 plus x, please. Square root of 1 plus x times 1 is going to give us positive square root of 1 plus x. Now, minus 1 times this is going to give us negative square root of 1 plus x. 1 plus x. The minus 1 times positive 1 is going to give us minus 1, all divided by the denominator, which is x times this, which is x, the square root of 1 plus x plus 1. All right, so this is positive, this is positive. Sorry, this positive is negative, so this cancels out, and then we have a plus 1 here and minus 1. That also cancels out. So if you pay very close attention, you will notice that what we have on the numerator is just x, right? So the limit now is going to be x all over the denominator, which is x, root of 1 plus x plus 1. So obviously this has been simplified. So if you plug in this limit of 0 into this fraction, you notice that it will be clearly defined, meaning we've been able to overcome this challenge we had there. All right, because in mathematics you're not supposed to have an undefined fraction. So that is why we have to go through this process to be able to simplify equation and then factorize and then bring it to this form. So obviously this is workable. So let's go ahead and plug in our 0. But before then, we can still go ahead and cancel this out. All right, so we're having x divided by x is going to give you 1. The limit now of x when x tends to 0 is going to be 1 all over the square root of 1 plus x plus 1. Now, if I'm plugging it, you will notice something, please. You pay attention and notice that I haven't used an equality sign ever since we've been solving this. So in limit, the only time you introduce an equality sign is when you're ready to plug in your limits. And our limit here is what? 0. You're right. So now let's go ahead and plug in. So since we are plugging our limit, I'll go ahead and introduce an equality sign here. All right. So now I'm going to have it that 1 all over square root of what? 1 plus, instead of x, I'm going to have a 0 in place of the x, plus 1. If you solve this, you're going to have 1 all over 2, right? So we've been able to kind of simplify this fraction, right? This limits, this mathematical problem on limits. And I believe you followed the process, you paid attention, you learned some principles in mathematics. All right. So for more challenging solutions like this, I want you to hit the like button, follow us, and drop a comment.